So this is more of evaluating composition of functions. So since we did that practice on the last one, I'm just going to help you set these up. This should be pretty quick. So number 9a, it's asking you to find the value of f of g of -2. So the first thing I need to do is find g of -2. So I'm going to take my g function, which is 2 times x squared, and I'm going to put in -2 there for my g of -2 and square that. That gives me 2 times 4, and 2 times 4 is 8. So now I'm going to evaluate the f function when x is 8. And that equals -2 times 8 plus 3, which equals -16 plus 3 is -13. So this first one equals -13. The second one, you're evaluating g of f of -2. So you're going to let the x function or the f function equal -2 for x. So -2 times -2 plus 3. Well, -2 times -2 is 4 plus 3 is 7. So I'm evaluating g of 7. And the g function is 2 times x, which is 7 squared. 7 squared is 49 times 2 is 98. So this equals 98. So it says, what is the composition of f of g of x? Well, f of the g of x function, which is 2x squared. So I'm going to take 2x squared and replace the x in the f function. -2 times 2x squared plus 3 distribute equals -4x squared plus 3. And the second one, what's the composition of g of f of x? Well, g of, let's see, f of x is -2x plus 3. So I'm plugging that into 2 times the quantity x squared. So this is getting plopped in here. So 2 times -2x plus 3, the quantity squared. Well, that means I need to take -2 plus 3 times -2x plus 3. This gives me 4x squared minus 6x minus 6x plus 9. So I have 4x squared minus 12x. I can combine these. Plus 9. And don't forget, you have to multiply that 2 on the outside. So this actually ends up being 8 x squared minus 24x plus 18. So for this last one, you're adding and subtracting the functions. So you're going to add f and g of x. You're going to subtract them. Then you're going to do the composite. And your this is actually a multiplying the functions, and this is a division of the functions. So let's add them first. Taking x squared plus 2x minus 3, and I'm adding that to the g of x, which is x plus 3. So -3 and a +3 cancel each other out. 2x plus 1x is 3x, x squared. So here's your first one. F minus g of x. You got to be really careful when you subtract. So the f of x function, x squared plus 2x minus 3 minus the g of x function. So I have a negative outside the quantity of x plus 3. Remember that that's the same thing as having a -1 here. You need to distribute that. So I'm going to rewrite this as x squared plus 2x minus 3 minus x minus 3. So I have to distribute that negative. So a -3 and a -3 give me -6. 2x minus 1x is x, and I have x squared. So this is the subtraction function. The next one is multiply. You're taking f of x times g of x. So f of x, which is x squared plus 2x minus 3 times x plus 3. Well, whenever I have a trinomial times a binomial, I know that you guys like to use the box method. So we're going to draw a box. That helps you think about that the best way. So x squared, positive 2x, negative 3. So this is a 3 by 2 box. X times x squared is x cubed. X times 2x is 2x squared. Negative 3 times x is negative 3x. Now we're going to do the bottom. 3 times x squared is 3x squared. 3 times 2x is 6x. And 3 times negative 3 is negative 9. Remember that you can typically, not always, but typically you can add the numbers on the diagonal, combine like terms. So I end up with x cubed. 3x squared plus 2x squared is a positive 5x squared. 6x minus 3x is a positive 3x minus 9. So this is what happens when you multiply the two functions. And the last one is a division. The last one is division. We're dividing f of x, which is x squared plus 2x minus 3 by x plus 3. So the only way that you can do that right now, that what you guys know, is I can factor this. X squared plus 2x minus 3, well, that came from the two factors, the two binomials, x plus 3 times x minus 1. And remember, if you don't believe that, you can always put this into a box and check it. X minus 1, x plus 3, x times x is x squared, x times negative 1 is negative x, 3 times x is 3x, and 3 times negative 1 is negative 3. It gives me x squared, 3x minus 1x is a positive 2x minus 3, which is exactly what I have in the numerator. My denominator is the quantity of x plus 3. And you see that you have the same thing in the numerator as in the denominator. So you're able to cancel those out, and you're left with x plus 1. But you have a domain restriction on this, right? Because you're dividing, and you can't let your denominator ever equal 0. So if x is ever negative 3, you're going to get a 0 in the denominator. So you're just going to say that x cannot equal negative 3. X cannot equal negative 3 because that would give you a 0 in the denominator, and you cannot divide by 0. Number 11 is about using the inverse function. So if f of x equals 3x minus 2, then the inverse of f of x, well, so here's what that looks like. Remember, this is a y. F of x is the same thing as y. When you're doing the inverse of a function, you actually just trade places with the x and the y. You trade places. So this really says x equals 3y minus 2. And then you have to solve for y. So the first thing I'm going to do is add 2 to both sides. So x plus 2 equals 3y. And then I'm going to divide both sides by 3 to get y all by itself. So y equals x plus 2 all over 3. That is the inverse. So f of, like the inverse of f of x is x plus 2 over 3. And then it asks us to graph them both. So this is just a linear function. 3x minus 2, that tells me to begin at 2. And I have a slope of 3. Up 1, 2, 3 over 1, 2. Up 1, 2, 3 over 1, 2. 1, 2, 3 over 1, 2. Up 2, 3 over 1. Sorry, I did that wrong. Dang it. Slope of 3. Up 3 over 1. Up 3 over 1. Up 3 over 1. Up 3 over 1. I could also go down 3 into the left one. Down 3 into the left one. So this is f of x. So remember I said that the when you do the inverse, you're actually flipping, you're reflecting over the line y equals x. That's this red line right here. I really want to draw that nicely so you can see it. So it's just a line that has a slope of 1. That's what this is, passing through the origin. So let's graph this. So I'm going to pick some x values that are going to give me numbers that are divisible by 3. So I'm only going to graph numbers that are divisible by 3. So x plus, so if I let x equal 1, I'm going to let x equal -5. If x is -5, -5 plus 2 is -3, divided by 3 is -1. If I let x equal, sorry, brain dump. If I let x equal 4, -4, that's 2, -3, -1, 0. If I let x equals 1, sorry, 1 plus 2 is 3, divided by 3 is 1. If I let x equal 4, 4 plus 2 is 6, divided by 3 is 2. If I let x equal 7, 7 plus 2 is 9, divided by 3 is 3. So I really struggled with finding the 0 value on that. I'm not sure where my brain is today. So let's plot those points. And I'm going to do that in bright green. So when x is -5, y is -1. When x is 1, y is 1. They're all on the same point. When x is 4, y is 2. When x is 7, y is 3. So this has a slope of -1/3. Or a slope of 1/3, not -1/3. So that's what this looks like. So this is the inverse, f of negative, f inverse of x. So it's reflected over that red line. You know that because the distance is the same from each point. The distance is the same. Okay, so that's how you're going to do those.